we've talked about systems already, and I think that is very clear enough. But right now, let's dive into calculations on enthalpy. And to do that, I would like us to understand that you can't carry out any calculation without understanding certain laws when it comes to chemistry, usually. For this particular calculation, we'll be looking at two laws, and that's the Lavoisier's and Laplace law, as well as the S law. The Lavoisier's and Laplace law states that during a chemical reaction, the forward reaction and backward reaction have the same amount of energy. Just that if the forward reaction is exothermic, the backward will be endothermic. For example, if I have A plus B giving me C, and the change in H is equal to plus 273 kilojoule per mole, it means that if I do C equals to A plus B, I'm going to get a change in H that will now be what? Negative 273 kilojoule. So while the forward reaction is endothermic, the backward become exothermic. That's just the summary of this law. And this second law states that every single time you have a reaction that has more than two ways of producing it, maybe directly or double steps. Let's say, for example, I have a way of producing a particular substance. There are two methods to use it. To do that, number one, maybe I can do directly step that in one single step, or I can use two steps. Whether I use one single step or I use two steps, I will get the same amount of energy that will be involved. And that's what the second law states. So that's very simple. But for this purpose, today we will be dealing with these examples, and let's see how we can solve them using our laws. So calculate the heat evolved when 0.20 mole of carbon 4 oxide is formed from its elements. The standard heat of formation of carbon 4 oxide is minus 393 kilojoule per mole. What does this really mean? First off, from what we can all see, we are seeing a negative sign here, which means the reaction that brought about CO2 is an exothermic reaction. And if you're a good chemistry student, you will have known that you have to burn carbon in oxygen to produce CO2, which is what? A kind of combustion reaction. Heat is being liberated. And that's why we have a negative sign here. That's one. And another thing I want to also see is what? This word here, standard heat of formation. Anytime you see standard heat of formation or standard heat of anything, it simply means that it's the amount of heat required that either evolved or absorbed to produce 1 mole of that substance at standard temperature and pressure. Usually what we call standard temperature and pressure. Standard temperature is 25 degrees Celsius, which people usually call room temperature, if you like. Okay, let's see how we deal with this question. First off, equation. Okay, let me put that here. Just know that I'm trying to solve the first question right here. I'll begin with the equation of the reaction. Now, what is the equation? How will I write the equation? So I have C plus O2 to give me CO2. Of course, this is solid. This is gaseous. This is gaseous. So looking at this, for us to get 1 mole of CO2, we need 1 mole of carbon. So we have CO2 being formed when we have 1 mole of carbon reacting with 1 mole of 1 molecule of oxygen, and thereby giving us 1 mole of this, as we've already discussed. So if we say that this 1 mole requires this energy, well, let me even write something here so that you can understand what I'm saying. I have to quickly write the change in enthalpy that happens here. Change in enthalpy here is minus what? 393 kilojoule per mole. Now, with this in mind, it means that 1 mole of CO2 needs to what? We lose 393 kilojoules of energy. Is that clear? So we now have 0.2 mole. We're giving, this is standard. This is given from the question. So we have what? 0.2 mole of the same CO2 will give us what? X. Just do your simple cross multiplication and then you're done. So we have 1 times x gives us x, and 0.2 mole times minus 393 kilojoule. We'll just get the answer in a very 6 kilojoule. Okay. It therefore means that it will take minus 78.86 kilojoule to actually produce a 0.2 mole of CO2. And next, so second question, I'll quickly solve that right here. So follow me as I use this end of the board to finish up our second question. So the heat evolved when 1.0 mole of methanol is completely burnt in oxygen is 22.8 kilojoule. Calculate the molar heat of combustion of methanol. Now, this question is a little bit tricky and different from this one. The first one gives us the standard, asking us to look for, shall I use the word, okay, not standard. Let me use the word substandard in that sense, because it's not 1 mole. But in this case, we are giving the one of what? The heat evolved when 1.0 mole of this is this. Calculate the molar heat of combustion of methanol. Very, very funny. Imagine you're writing JAMB and you see this kind of question. Most of us start freaking out, thinking that they've just gotten you. But your question says the heat evolved when 1.0 mole of methanol is completely burnt in oxygen is 22.8 kilojoule. In your mind, what should you do? Per 1 mole. That's still standard. So if you're asking me to calculate the molar heat of combustion of methanol, the answer is still what? 22.8 kilojoule. So these are things that JAMB plays around and still already freaking out. You're not supposed to even pick up your calculator with this one. You just pick your answer and move. But let's tweak it a little bit. What if it was supposed to be gram? And that's what we want to leave you, and that is going to be a little bit different here. So for us to be able to do this one clearly, we have to know how to write combustion reactions. And how do we write methanol? So let's start with the equation of a reaction. Methanol is CH3OH. And when you talk about combustion, it means you have to react it with oxygen, and you will get, of course, for those that know, you get CO2 and you get water. These are the results that you always get whenever you burn a substance in oxygen. It's really a carbon containing compound, rather. So, is it balanced? All right. So, looking at this equation, you have to balance them quickly. And if you're going to balance them, you have to go with this formula here, where your X represents the value, the number of carbon atom, your Y represents the value of the number of your H atoms. And when you put everything in line, you're going to be getting, this is what you're going to be getting at the end of the day. You're going to be getting 2CH3OH plus, you're going to be getting this 3O2, resulting in 2CO2 plus 4H2O. If you check it very well, everything is balanced already. So if we say that methanol is 1 gram and produces this value, what do you think we really have to do in this equation? So how many gram would this be? Still the same way we have actually worked out things. Don't stretch your head too long. What is the value of? So CH3OH is 1 mole. And the result of this will be 12, which is carbon, plus 1 times 3, which is your oxygen, and the hydrogen, plus your oxygen 16, plus another 1, which is, if you do all the maths together, you'll be getting 12 plus 3, which is 15. 15 plus 16, that's 20, I think that's 31 plus 1, that will be 32. So you have 32 gram per mole. That's the atomic mass. That's the molecular mass of 1 mole of, that's the molecular mass of methanol. And if that is true, then let's play the game in a very easy way, the way we did the other time. If 1 gram, put methanol somewhere here, CH3OH, and put your energy right here. I think it's going to be very easy. So let's put that around. We have given the question is what? Remember how we did that time? 1 gram, right? 1.0 gram. Then what's the energy I was giving alongside that? 22.8. So what do we have for standard normally? For standard, if you have what? 1 mole, abi? And 1 mole, let me put the gram so you can understand it's in gram. 1 mole should be what? 32 grams. And here will be what? X. So just play again the way I've been playing that. If you solve that, we'll be done. So X will be equal to 32 times. So when we do our cross multiplication, we're going to get this result. So the answer will just be get your answer when you multiply this, and that will be pretty easy. Joule per mole. Okay, so now that we have this value, you want to ask yourself, will it be negative or positive? Never forget, every time you're doing combustion reaction, it's an what? Exothermic reaction. So you have what? A negative answer. So, and this is what it will be. What if somebody twisted your mind and tell you what 10 moles? Just this is per mole, multiply by 10, and you're good to go. And that's how you do it. Calculation on enthalpy. Thank you very much for staying tuned to this time. I hope to see you pretty soon in our next video.